Hello, this is Gregory Maxwell, and we again have a video. And today's video is on circles. And I'd like to thank Professor Shauna Hader of Salt Lake Community College, from whom I have gotten most of the slides on this PowerPoint presentation on circles. So let's get started. Now, a circle basically is the set of all points in the plane. The old word is locus. The set of all points in a plane that are the same distance from a particular point. So all the points in a plane that are equidistant from a point, and that point is called the center of the circle. Now let's talk about how we get the equation of a circle that whose center is the origin. In essence, all the points that are the same distance from the origin. Let's call that distance r, and that r is called the radius. So we choose a point on the circle, x and y. X, y are the coordinates, and the distance from x, y to the center of the circle is r, the radius of the circle. So all the points that are equidistant from the radius, from the center, sorry, have the same, have a distance of r from the center. Now, how do we get the equation here? First, we're going to identify that the x-coordinate is simply the distance from horizontally from the x-axis, and the y-coordinate is the distance, sorry, the x-coordinate is the distance horizontally along the x-axis from the origin, and the y-coordinate is the distance vertically along or parallel to the y-axis from the uh, origin, the distance along the y-axis from the origin, or the perpendicular distance from the x-axis. As you can see in my little diagram here, when I drew that little dashed line, it forms basically a right triangle, which brings to mind the Pythagorean theorem. The Pythagorean theorem says leg squared plus leg squared is equal to the square of the hypotenuse. In this case, since the legs of this triangle that I've just constructed with the radius being the hypotenuse, the legs are x and y, then leg squared plus leg squared becomes x squared plus y squared, and the hypotenuse squared is the square of the radius. So now we have the equation for a circle that is centered at the origin. And that equation is x squared plus y squared is equal to r squared. So that's the basic equation for a circle centered at the origin. Now, let's take a quick look at an example here. So this form of the equation of a circle is called standard form. And I will clarify some other forms as we go along. But right now, x squared plus y squared equal to r squared. Please note that the r in the equation, r is the radius, so we're squaring the radius as part of the equation. So if you have an equation like this, you remember you need to square root the right side in order to get the the the, the radius. All right. So I also want to point out that both x and y are squared, and their coefficients are exactly the same. If the coefficients are not exactly the same, then we're not dealing with a circle here. We may be dealing with another shape, such as an ellipse or a hyperbola. Now, let's take a look at an example. X squared plus y squared equal to 9. Now, as you can see, that this looks just like the equation that we had. In this case, 9 is r squared, so that would mean r is 3. And since it's x squared plus y squared equal to r squared, then we have this circle has the center of the origin, and its radius is 3. Now, how do we graph this circle? To graph this circle is pretty simple. You need 5 points. The first point you will need is the center, in which case it's the origin. Then you need 4 other points that are a distance of r units from the center in the 4 directions, to the right, to the left, up, and down. So first we plot the center, in this case 0, 0. Then we need 4 points, 3 points to the right, 3 points above, 3 points to the left, 3 units downward. And the 3 here is because the radius is 3. And then we draw as smooth a curve as we can to form a circle. And that is the easiest way to draw a circle. You first plot the center, and then you uh, plot 4 points using the radius, and then draw the circle there. Now, let's talk a little bit about the equation of a circle that is not centered at the origin. Instead, it's centered at a point HK. So let me draw a circle here, and there we have the center HK. In this case, if I choose a point on the circle XY, now I'm not only concerned about the distance from the origin, I'm actually talking about the distance from the center. Well, that distance from the center is still R, the direct distance, but the horizontal distance and the vertical distance are talking about how far x is from h, that's the horizontal distance, and how far y is from k, which is the vertical distance. So the distance from that x is from h is x minus h, and the distance y is from k is y minus k. So we have a right triangle again, and with the Pythagorean theorem comes into play, but this time the legs are x minus h and y minus k. The radius is still r. So the equation now becomes x minus h squared plus y minus k squared equal to r squared. And that is the equation of a circle whose center is at a point hk. I'd like to point out that if h k are the is 0 0, the origin, the equation goes right back to the original x squared plus y squared equal to r squared. So let's take a quick look at this example here. This radius, this form is sometimes called standard form, but I prefer to call it center radius form because there's a little bit of confusion. And another form is also called standard form, and that form I call general form. So in this case, PowerPoint, in this video, we will refer to this form as center radius form. So please note that in center radius form, it's x minus the x coordinate of the center and y minus the y coordinate of the center. X minus h and y minus k. So if I have an equation like this, x minus 3 squared plus y minus 1 squared equal to 16 squared, we realize that h must be 3, k must be 1, and remember this is r squared is 16, so r is 4. So we're talking about a circle whose center is as coordinates 3, 1, and the radius is 4. How do we graph that? First, we identify the center. Then we do 4 units to the right, 4 units to the left, 4 units up, 4 units down. And that is the equation, that is the graph of the circle whose equation is given here in center radius form. Center radius form. Now, let's take a look at another situation here. Another situation. In this case, we have an equation x plus 2 squared plus y minus 4 squared equal to 4. As you can see here, since 4 is r squared, then the radius is 2. And this is actually x minus negative 2, so h is negative 2, and this is y minus 4, so k is 4. So the center is negative 2, 4, and the radius is 2. But what if we distribute? What if we distribute the parentheses? We FOIL x plus 2 squared and y minus 4 squared. When we do that, we get x squared plus 4x plus 4 for this x plus 2 squared, and we get y squared minus 8y plus 16 for the y minus 4 squared, and of course the 4 is still on the right side. If I get the number to the right, if I get this 4 to the left side, I just subtract 4 from both sides, and this 4 and this 4 would of course cancel, and I put the x squared and the y squared next to each other. So I have an equation that looks like this: x squared plus y squared plus 4x minus 8y, and then plus 16 because the 4's are left behind. That form of the equation of a circle is called general form. Now, this is where a little confusion can occur. It's this form, general form, is sometimes called standard form elsewhere. So I'm going to call this general form, and the other form, as I said, I'm going to refer to as center radius form. Now, what if you start out with general form and you want to find the center radius form? What we will do is complete the square because we're working backwards to perfect square binomials. First, I move the 16 to the right side, the constant to the right side. So I'm going to subtract 16 from both sides. And then I'm going to put the x's together. So I'm going to put x squared and 4x together. And I'm going to do that with the y's as well. Y squared and negative 8y together. Since I want to make a perfect square, I'll have to add a number here right after the x and a number right after the y that will make this into a perfect square. And whatever I do on the left side, I must also do on the right side. So what am I going to add here? To make this expression into a perfect square, since the coefficient of x squared is 1, we take 4, divide it by 2, and square it. And that will give me 4. And so I'll add 4 to both sides. And then I'll do the same thing with negative 8. I will divide it by 2, which will give me negative 4, and then I'll square that, and that will give me 16. So I would add 16 to both sides. So completing the square on both sides will give me a 4, and a 4, which I'll add on both sides, and a 16, which I'll add on both sides. And then I can just factor each of these trinomials. X squared plus 4x plus 4 is a perfect square trinomial. It factors to be x plus 2 squared. And y squared minus 8y plus 16, it factors to be y minus 4 squared. And the right side is, when you add all the numbers together, you get 4. And we are back in center radius form. So if you're given the equation in standard form and you're told to find the center radius form, then you simply do completing the square for the x's and the y's. Now, here are a few examples that we're going to do. So what is the equation of a circle with center 0, 0 and radius 7? Now, since the center is 0, 0, we'll write our standard form of an equation, which is x minus h squared plus y minus k squared equal to r squared. The center is 0, 0, so I'm going to replace all my h's with 0 and my k with 0, and the radius is 7, so I'm going to replace r with 7, and then simplify. X minus 0 squared is just x squared, and y minus 0 squared is just y squared, and 7 squared is 49, and there we have it. I'm just going to leave that there on top so that you can see it for the sake of the notes. Now, that's how simple that was, because the center was 0, 0, and the radius is 7. The center and the radius are given. In this case, we're told again that the equation has a center of 0, 0, but now that it passes through the point negative 4, negative 1, negative 4. So in this case, we're not told what the radius is. We are only told a point on the circle. So what we do is we write our equation, and we already know the center is 0, 0, so h and k are 0, so the equation becomes x squared plus y squared equal to r squared. Now, to get the form of the equation, we need to figure out what r squared is. That's not a problem, because we have a point on the circle. X coordinate negative 1, y coordinate negative 4. So what I will do is substitute for x, negative 1, and for y, negative 4, and solve for r squared. When I do that, I get that r squared is 17. So then in this equation, r squared is 17. The equation becomes x squared plus y squared equal to 17. Remember that x and y are variables, and when we substituted negative 1 and negative 4, we only substituted one instance of one point that is on this circle. R is, on the other hand, is a constant. It's a radius. It never changes for the circle. So once we find that constant, we're good. By the way, the radius is not 17 here. The radius is the square root of 17. R squared is 17. That means R is the square root of 17. Here's another question where we are given the center is a different point other than the origin, but the radius is given as 6. This one becomes pretty straightforward as well. We just write the equation of the circle, x minus h squared plus y minus k squared equal to r squared. Replace h with negative 2. We replace k with 5, and we replace r with 6, and we simplify. X minus negative 2 is x plus 2. Y minus 5 is y minus 5, and 6 squared is 36. So the equation becomes x plus 2 squared plus y minus 5 squared is equal to 36. And that is how easy it is. That is center radius form. Here's one where the center is at a point other than the origin, and the circle passes through a point 8, 0. Well, we write our equation, x minus h squared plus y minus k squared equal to r squared. We know h and k because those are the coordinates of the center. So we insert 8 and 2, and then we need to find r squared. But again, we have a point on the circle with coordinates 8 and 0. So for this particular instance, H and K are always the same for this circle. The center of the circle doesn't move, but X and Y is always changing. Those are variables. At a particular instant, the X coordinate is 8 and the Y coordinate is 0. So I just substitute 8 and 0 for those values into the equation and then solve for R squared. When I solve for R squared, I see that R squared is equal to 4. So now I know what R squared is. My equation becomes X minus 8 squared plus Y minus 2 squared equals to 4, which means the radius of the circle is 2. The radius of the circle is 2. Now let's go on to another example. In this case, this looks a little weird. The radius, the equation kind of looks like this: x squared plus y squared equals r squared, but the x squared and the y squared have a coefficient in front of them, namely 9. Note again that both coefficients are exactly the same. If that was not the case, this would not be a circle. So what we do is, to make our lives easier or to make it workable, we need the coefficient of x squared and the coefficient of y squared both to be 1. So the best way to do that is to divide both sides by 9. When we do that now, our equation looks like what we're used to: x squared plus y squared equal to r squared. This 64 over 9 is r squared, which means r is the square root of 64 over 9, which is the square root of 64 and the square root of 9. That's 8 over 3. And since it's just x squared plus y squared, then we know the origin is the center of the circle. So the center is origin 0, 0, and the radius is 8/3 or 2 2/3. So to graph this equation, I simply plot the point, the origin, then go 2 2/3 to the right, 2 2/3 to the left, 2 2/3 up, 2 2/3 down, and I have myself the graph of the circle. Now, let's take a quick look at another example here. In this example, we want to identify the center, the radius, and this equation is in center radius form. So it's pretty simple. We know that the center radius form is x minus h squared plus y minus k squared equal to r squared. In this case, then, to get x plus 4, we're saying x minus negative 4. So the h is negative 4, and then of course k is 3, and the radius is 5, which is the square root of 25. So we plot the point: negative 4, positive 3. That will go 5 units to the right, 5 units to the left, 5 units up, 5 units down. And there we have it. Now let's go into something a little bit more challenging. An example that's a little bit more challenging. And in this case, what we're going to do is we're going to find the center and the radius of this circle. The center of the radius of this circle. And I'm not going to plot this one, but you can plot it from there. Well, we're going to first complete the square. So we're going to first move the 3 to the right side by adding 3 to both sides. Then I'm going to put the 6x next to the x squared and the negative 4y next to the y squared. Then I want to make a perfect square, so I'm going to create a space after the x squared plus 6x and a space after the y squared minus 4y to make it into a perfect square trinomial in both cases. But whatever I add to the left side, I will also add to the right side. So whenever I add a number to this here, for the x's, I'll add it over on the right side of the equals as well. And I'll do the same thing with the y's. Well, to get the perfect square, the coefficient of x squared here is 1, sorry. Likewise with y squared. So I just take the 6, divide it by 2, which is 3, and square that number, and that gives me 9. So I'd add 9 to both sides. Then the same thing with the negative 4. I take the square root, half of negative 4 is negative 2, and when I square that, I get 4, which I will add to both sides. And now I factor the equation, the expressions: x squared plus 6x plus 9 gives me x plus 3 squared. Y squared minus 4y plus 4 is y minus 2 squared. And 3 plus 9 plus 4 is 16. So therefore, the radius, the center of the circle is at negative 3 comma positive 2. And this radius is 4, which is the square root of 16. And there we have it. Let's continue. Now, I'm going to do a couple of examples. I'm going to write these examples up as a step-by-step. So we want to find the equation of a circle whose center is the point 2, 3, and the tangent is its tangent to the x-axis. Tangent to the x-axis means that it touches the x-axis at one point, it bounces off the x-axis, so to speak. So what I'm going to do is I'm going to draw the x-axis, and I'm also actually going to draw the y-axis as well. And we're going to see what this looks like. So that's the x-axis, that's the y-axis, and then I'm going to draw a circle here. So let's draw a circle. I'm going to use a different color. Let's use red. And I'm going to draw a circle such that its x coordinate is 2, y coordinate is 3. So let's say it's about like right there. And I'm just going to draw it so that it looks like that. And there we have the circle tangent to the x-axis. It's kind of rolling on the x-axis. If you look at this now, you realize the center being 2, 3 means the circle is 3 units away from the x-axis and 2 units away from the y-axis. That 3 units away from the x-axis means since the circle is touching the x-axis, its center is 3 to one edge of the circle is 3 units, which means the radius of the circle is 3. The center h and k are 2, 3, and the radius is 3. So we start out with the equation of the circle, x minus h squared plus y minus k squared is equal to r squared. Now, from the radius, from the center, we know that h is 2 and k is 3. So we can then say, just to solve this equation in center radius form, I just say x minus 2 squared plus y minus 3 squared is equal to 3 squared. And that now can just be written as x minus 2 squared plus y minus 3 squared is equal to 9. And there we have our equation of the circle in center radius form. There we have it. Now, let's see what's going on with this one here. In this case, we have a circle whose has endpoints 1, 4, and -3, 2. So I'm gonna draw a diagram to illustrate what's going on with this one, and we're gonna see how we're gonna approach this. We want to find the equation of a circle. I'm gonna draw a little circle over here. This is just a rough representation. It's not gonna be drawn to scale, but basically we have 2 points on the circle. One is 1, 4, and one is -3, 2. So we're talking about going to the right and up, and then going to the left and up as well, but not as much up as before. So it would probably look something like this, starting on this end, going through the origin and stopping at that end. And therefore, this coordinate would be 1, 4 in the first quadrant, and this would be -3, 2 in the second quadrant. All right, and then that indicates then to find the center of the circle, HK. That's in the midpoint of the diameter, because the diameter goes right through the center. So the center of the circle then is equal to the midpoint of the diameter. And therefore, we can then say HK is, and midpoint formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. And then we can just solve for, plug in the particular values, h and k equal to -3 plus 2 plus 1 divided by 2, comma, 2 plus 4 divided by 2. And that will give us -2 over 2 and 6 over 2. So the center of the circle then, HK, would have coordinates -1 and +3. That would be H and that would be K. And now we can find the radius by doing the distance formula, or find the distance of the diameter and then dividing it by 2, or find the distance directly from HK to one of those 2 points. But another way we could do it is like what we just saw in the PowerPoint. Write the equation of the circle in center radius form, x minus h squared plus y minus k squared equals to r squared. And then we are going to choose one of these points, and we can choose, say, 1, 4. So we know that HK is that, and let's use point on the circle, because it's the end point of the diameter, so it's a point on the circle, 1, comma 4. I could have used the other point as well. So we're going to plug them into this equation here. We're going to substitute x is 1, h is -1, y is 4, k is 3, and r squared we don't know, but that's now becomes easy. 1 minus 1 is 2, so we have 2 squared plus 1 squared, and that gives us 5. So r squared is equal to 5. And that means the equation, so the equation of the circle then, in center radius form, is x minus h, which is x plus 1, squared, plus y minus k, which is y minus 3, squared, is equal to r squared, which we just found out to be 5. Please note then that the center we already identified is -1, 3, and the radius is square root of 5, because r squared is r squared is 5, and so to get r you just do the square root of 5, and we are back in business. Let's do a couple more examples here, a few more examples come along. Says the question here says, write the equation of the given set of points and then graph the equation. So in this case, we want to find the equation of all points that are 3 units from the point -1, 2. Now, based on the description here, 3 units from a particular point, that's the description of what a circle is. All the points that are the same distance from a particular point. So what we're saying here is that all points equidistant, that means of equal distance, equidistant from the point -2, 1. So the center of the circle, HK, is that point, -2, 1. That's HK. And then the distance is the radius, and the distance from that point is 3 units. That's r. So then we have x minus h squared plus y minus k squared equals to r squared. So we do x minus -2, which is x plus 2 squared, plus y minus 1 squared is equal to 3 squared, which is 9. And that's our equation. Now let's graph it. I'm going to draw the axes, which are its x-axis and y-axis. Then my center is negative 2, 1, so I'm going over to the left negative 2 and up 1, and then I'll mark that as my center. Then the radius is 3 units, so I'll go 1, 2, 3 units to the right. I'll just use a different color here. And then I'll go 3 units up, 1, 2, 3. And again, I'm doing a rough sketch here instead of an exact graph. I would recommend you do an exact graph, but I'm just doing a rough sketch for the sake of this video. I go to the left, 1, 2, 3 units, and downward, 1, 2, 3 units. And then as much as I can, I try to draw a smooth curve. It's not going to be perfect since I'm doing it with my free hand, free-handedly, but it's just approximate. So we have a somewhat circle here. The coordinates of the points on the circle, we can actually tell. The center of the circle we know to be negative 2 comma 1. And if I go 3 units to the right, my y coordinate is the same, but my x coordinate is now 1 comma 1. If I plug those in, I get 1 plus 2 squared is 9, minus plus 0 is 9. If I go up, my x coordinate stays the same, but my y coordinate becomes 4. If I try that, I get 0 here, and 4 minus 1 squared is 9. If I go to the left, my x coordinate is going to change to negative 5, and my y coordinate will remain as 1. And if I go down here, my x coordinate is going to remain at negative 2. My y coordinate is going to become negative 2. And you can plot those and see that those are points on the circle. Now, let's go on to this other question, similar to one I just did in the PowerPoint. Find the equation of a circle at the with center negative 2, 9, with point on the circle 8, negative 7. Standard question, very easy to do. And I would encourage you to try it before I go through the answer here. Simply put, I identify my h and my k. The center is negative 2 comma 9, so that means h and k are negative 2 and 9. And then I write my equation, x minus h squared plus y minus k squared is equal to r squared. I already know h and k, so that becomes x minus negative 2 squared plus y minus 9 squared is equal to r squared. And in order to find r, we replace, we're going to use a point on the graph that they give us. It's a point on the circle. That point is 8 comma negative 7. So I'm going to replace all my x's with 8 and my y's with negative 7. And that will give me r squared. 8 plus 2 is 10. So we're talking about 100. And negative 7 minus 9 is negative 16. And the square of negative 16, I believe, is 256. And then we add that to 100. And that means r squared is 356. And that one, if we want to find out what r is, we just do the square root of 356, and that will give an approximate value. So r is equal to the square root of 356, which is approximately 18.868. Not exact, but I'm just doing that for an estimate for the graph. Now, to graph this, I don't have quite enough space to graph this graph. So what I will do is I will just do a rough sketch of the of the graph, and I'll just plot some points to indicate what I'm talking about. So the equation then, I forgot to write that here. The equation of the circle is x plus 2 squared plus y minus 9 squared is equal to 356. And with a as large a radius as that is, this coordinate would be -2 comma um, -2 comma 9, and then we would go 18.87 units to the right. So we're talking about approximately 16.868 comma 9. And if I go to the left, I'm talking a point at negative 20.868 comma 9. And then if I go up, I'm talking about -2 comma 27.868. If I go downward, I'm talking about -2 comma -9.868. And that's basically what the graph generally would look like. You would have to plot the axes here, but I'm not going to go into that right now. So we have our answer right there. Let's go on to another example. Last two examples here. Write the equation of the circle in center radius form and graph it. So let's try this one quickly here. Now, since the coefficients of x squared are all 3, x squared and y squared are 3, I'm going to divide everything by 3. So I end up with x squared plus y squared plus 8x minus 6y plus 8 equal to 0. That's dividing everything by 3. Then I'm going to put it in the form that I need for completing the square. I'm going to put the x's together. And I'm going to create a space for the perfect square. I'm going to put the y's together. I'll create a space. And then I'm going to subtract 8 from both sides and create 2 spaces for the numbers that I add on. Now the numbers that I add on is I'll divide this 8 by 2 and squared. That gives me 4. So divide by 2, I get 4, and I square 4, I get 16. So I'm adding 16 to both sides. And then in this case, I'm going to take -6 and divide by 2. I get -3. And when I square that, I get 9. So I'm adding 9 to both sides. And then when I do the perfect square over here, it's basically x plus 4, which is the 4 I got from dividing here, squared, plus y minus 3, which is a minus -3 I got from here, squared, and that's equal to 17. And that we have is our equation in center radius form. The center of the circle is -4 comma -3, and the radius of the circle is the square root of 17, which is just over 4. It's approximately 4.123. And so I'm just going to do a little shortcut here. I'm going to do a little sneaky. and I'm going to draw my graph. I made an error quickly. If you can point out what it is, I put -3. It's supposed to be -4 comma +3. So this point here is -4 comma 3, and then you go a little bit more than 4 units to the right, and that gives you approximately positive 0.123 comma 3. And if you go over to the left, you get -8.123 comma 3. And if you go upward, you have -4 comma 7.123. And if you go downward, you get -4 comma -1.123. And you can always fit the axis over at an appropriate spot around that. The axis probably is going to be somewhere, like down here maybe, and probably something like right there. Not drawn to scale, but you get the idea. Now, last example, and then I'll review some Khan Academy videos that you can look at. Right, the center radius form of the circle. Now, we can see here that this line segment looks like the diameter, and if it is, then this line segment should also be the diameter, and where they cross will be the center, and they cross at 1, 1. If those are both diameters, they'll be the same length, and half of that length will be the radius. So the length of this diameter is 1, 2, 3, 4, 5, 6, 7, 8. And the length of this is 1, 1, 2, 3, 4, 5, 6, 7, 8. And so we're correct. So the center of the circle, HK, is 1, 1. And the radius of the circle is 4. R equals to 4. And so the center radius form of the equation, the center radius form, of course, that comes from x minus h squared plus y minus k squared equals to r squared. H is 1, so it's x minus 1 squared plus k is 1, y minus 1 squared equal to r squared, which is 4 squared, which is 16. Now to get the general form, what we do is we distribute the parentheses. So I'm going to go x minus 1 squared, which means x minus 1 times itself, plus y minus 1 squared, which is y minus 1 times itself, equals to 16. When I distribute the parentheses here, I get x squared minus 1x minus 1x plus 1, and then y squared minus 1 and y minus 1y plus 1, and then equal to 16. And then I put the x squared and the y squared together. Then I put the x term. Then I put the y term. Then I put the numbers together. 1 plus 1 is 2, and then minus 16 is -14, equal to 0. And that is the general form. There we have it. Now, before I end the video, I'd just like to point out a few resources on Khan Academy that are very helpful. We have 4 short videos here between 4 and 6 minutes. First one is features of a circle from its standard equation. That shows you how to get the equation of a circle from its center radius form. graph of an equation, a circle from standard equation, writing an equation in of a circle in standard form. All of these are dealing with center radius form, and then features of a circle from its expanded equation, which is a general equation, general form. Those are videos that I would encourage you to watch, and also to uh, to do the corresponding exercises on Khan Academy. That's all for this video. Remember to practice your mathematics, and don't take it for granted. It's not because someone does it for you means it's easy. You don't learn it until you do it. That's all for now. All the best.